Hi everyone. Today I'm going to talk to you about resilient deployments on ECS. So the presentation will be about containers, it will be about AWS, it will be also about deployments. So inspiration for this presentation is a blog post that CEO of our company has co-written with folks from AWS. And this article has been posted to a blog post on AWS website. And it talks about how we are doing deployments. And this presentation will be expansion of that article to give you some context. So as a context, our company has a big monolithic application. It's a Sinatra backend powering 2 mobile apps. And we observe around 350 million requests per day. And it's a customer-facing business. It's a dating app. And with a global reach. So being down, our application being down is really not acceptable. Yet we observe very high uptime. Like the application is almost never down. We are always up. So this presentation will show you how. So quickly about me. So I've started learning Ruby in 2016. Yet I started programming with a totally different technology, which is called Magic. And it's a proprietary language from General Electric used for geospatial information systems. I spent a few months working there, and then fortunately I was able to transition to Ruby, and I was happy ever since. And for the last 2 years, I've been managing infrastructure for high traffic Ruby application. So for personal motivation, I always found infrastructure topics to be quite interesting. Yet I was frustrated at knowledge silos that often happen in companies. So, you know, as a Ruby engineer, I would be writing some code, but then I didn't really know what's going on with it. So there were other people that were doing deployments, that were actually involved in operation of that code. So this was just a knowledge that was not available for me, and I grew frustrated at that. Fortunately, I've joined the ops team, and I wanted to share with you what I've learned. So agenda for today's meeting. We'll be talking about ECS, what it is. We'll be talking about deployment strategies. We'll be talking, and this will be a build-up into a production example of using all of those components, so you can see it in action, in the actual production system. After each section, there will be a pause. So if you have any questions, that will be a good time to ask them. And in the end, there will be a QA. So goals for this presentation is to give you insight into like tools that you might have not normally used, or expanded if you have. And share the knowledge that I've learned about running and deploying Ruby applications. So let's talk about ECS. So ECS is an AWS service which deals with container orchestration. So basically it means that it's a tool to run container in the cloud. So you can compare it to something like Kubernetes, but it's much simpler, and it's into AWS ecosystem. It has 3 main abstractions. So you have a task, and a task is a wrapper around a Docker container. You can specify what kind of image you want to run in this task. You can specify what kind of resource allocations you want. We have a service which which says what kind of tasks do I want to run and how many instances of that task do I want. And in the end, we have a cluster, and the cluster is a top-level entity in ECS. And if you want to do anything in ECS, you first have to create a cluster. Here is a visual representation, just to give you a little bit more context. So with dashed lines, you can see logical abstractions, and with solid lines, you can see actual physical entities. So for abstraction, we have cluster, we have a service, we have a task. But at the end, it's just your good old virtual server in AWS that would be usually EC2, running some containers. So just to give you another perspective on this tool, I will show you an example how would you actually get your Rails application into ECS. So typically you would start with a Docker file after creating your Rails application. Here you can see all the typical stuff, Ruby version specified, external libraries installed, and obviously like entry point, port 3000 exposed. With that, you would build it into an image. And the important thing that this image would need to be pushed to a place called ECR. And ECR is a AWS service. It expands to Amazon Container Registry. And it's a private registry in Amazon where Docker images are being stored. So they can be later retrieved for running tasks in the cloud. So that's a task definition. There is too much text already, and this is a simplified version. But the important thing is that you basically have to define this one file, and important stuff like family, so name of the task, and container definition. So we'll specify what kind of containers you are running in your tasks. And interesting thing, this is actually an array, so you can have multiple different containers in one task. Other notable things to configure are like what kind of image you want to run. So on the previous slides, we pushed some kind of image to ECR. So here we would specify its full URL, port mappings, and also any environment variable overrides that you want to put on top of what you have in Docker file or what you have actually in your application. So here are some. So we would obviously need to create a cluster, cluster is just a top-level namespace. It deals with what kind of resources are running your containers. So would that be EC2 instances or just a serverless technology like Fargate? You would need to define that. And with a cluster, you would create a service. And important thing, you would specify what kind of task this service is running. So in this case, that would be a Rails app. And also services deal with load balancing. So they deal with how the traffic is coming from the web to your services. And services actually manage automatically registration and deregistration for load balancers in AWS. So just by the merit of having the service, you have this capability by default. And then we have our app running in ECS. On this example, it's actually, it tries to start, but it can't. But let's say you've configured it correctly, not like I did, then it would run indefinitely. And that ends first part. Guys, do you have any questions?
I have one.
Yeah?
So you said that it's simpler than Kubernetes. I mean, I remember that Kubernetes had these pods, deployments, stuff like this. So how this translates to this thing?
I vaguely remember working with Kubernetes, so I don't have exact like one-by-one comparison. But generally speaking, like if you are in the AWS, you can also run your application in Kubernetes, but you don't get like all of the support. So different services in AWS have actually compatibilities. They allow you to perform actions with ECS. And an example could be a code pipeline, which has actually specific actions to deploy your code into ECS, which might not be the case for Kubernetes. So you can do it, but you would just need to write more code, basically. So in that sense, if you are in a cloud, like if you're in a AWS, it would be easier to use it.
Do you use any IOC infrastructure as code, like Terraform?
Yeah.
Because those forms in AWS were always a nightmare.
Yeah. Oh yeah, for sure. We do use Terraform, and yeah, it's great. It allows you to specify your infrastructure, and if you want to like have something similar, you just do Control-C, Control-V, and there it is. So we do use it.
So if I had a web server and a sidekick or some queue process, I would have two separate tasks for it, right?
Yes, you would have. So for Sidekick, you would have typically a task running container which runs Sidekick.
Yeah, okay.
So one service, two tasks, no?
Actually, they would be separate service. So let's say you have your application and your Sidekick. So you would define two services, and each service would be running different tasks, and one task would be for Sidekick, and one task would be for your application.
Okay, and is there any way to communicate between the containers in this setup?
So yeah, I mean,
like to, I don't know, do some like external like queue or whatever.
So there is no direct communication. I mean, but obviously, like depends on your setup. So if your containers are running on one host, on one virtual server, then they could still communicate, right? Since they are on the same network. But okay, you could like use load balancers to actually to communicate. There are different like types of communication technologies. But you could also just use like S3 to communicate. Like there are many ways to achieve it. All right, thanks for questions, and let's move to the second part. So we have our app containerized, running on ECS, and what are the next steps? Let's talk deployments. So for ECS, there are some strategies that are supported out of the box, and a default strategy for ECS is to do a rolling deploy. You can also have a blue-green deployment with the help of other AWS service, namely code deploy. But there are strategies that are not supported. And now I will talk to you about, in a little bit more detail, about deployment strategies themselves. So maybe you already know it, but I will go through it anyway. So there is a rolling deploy. And the idea here is that you would be typically removing application instances. Let's go back. You want to deploy a version 2 of your code. Your application servers are running version 1 of the code. So in a rolling deploy, you would typically remove one version 1 application and then add one version 2 application. And you would be do it to basically achieve everything on version 2. So we would remove one version 1 and then add one version 2 application. So in that sense, it's fairly straightforward. And for some of the pros and cons of that approach is that it is an inexpensive approach. It can be an in-place upgrade, basically. You don't need to spin any extra infrastructure. So since we know that cloud is very expensive, that's a big pro. It has a low complexity. It's basically supported out of the box in many cases. And for cons, you don't have any control. Like when deployment starts, you can only stop it, but you don't really control. You cannot say, okay, I want to deploy this part of my application fleet and not the rest, right? So that's one of these advantages, and the other is that it's slow to roll back. If you want to roll back an application deployed with rolling deploy, you need to do the same thing. So remove a server from version 2, add one server with version 1 until you have all servers at version 1. Blue-green deployment. So the idea here is that you have two environments. You have a blue environment and green environment. Blue environment is your old version of your code, what is currently running in production, and blue version is, has the newest one. So it has version 2 of your code. And the thing is that you would actually create both of those environments and have them running at the same time. So even though the traffic is, all the user traffic is going to blue deployment, you would still create a green one. And then when you're ready, you would flip a switch and all of the traffic would go to green environment. So this strategy allows basically for instant deployment. All of the traffic is shifted to new version of your application. It's also quick to rollback, right? Since as easy as it is to deploy it, you can simply switch back to green environment if there are any bugs on blue on blue one. For cons, it is expensive in the sense that you have to double your resources, basically create an extra replica of your application. And it has high complexity since maybe creating your production environment is difficult. And let's talk about the last deployment strategy. So that's a canary deploy. And with canary deploy, it is similar to a rolling deploy, but the idea is that you would you would deploy only part of your application servers to the next version, to version 2, and then see for any problems to manifest themselves. So for this, for pros, that's an expensive approach, similarly to rolling deploy, and you actually have a high degree of control because you can say, okay, I want to deploy only 10% of my servers and not the rest. But it's a slow deployment strategy since there is a pause in this deployment. Okay, and now I will maybe expand a little bit and say to you why canary deployments are amazing as someone who actually deals with those type of deployments. So there is this idea of reduced blast radius. So your user base, right? Like if you fuck something up and you deploy a bug into a production and it slipped past all of the tests, you don't really want everyone being taken down by this change. Like you don't really want your users, all of them, to lose access to your application. So if you only deploy to 10%, then, well, at worst, only 10% would be affected. There are also problems that manifest themselves over time. So you can imagine that there can be caches in your application that need some time to expire. Maybe some jobs run on different hours. So just letting this deployment bake for canary deployment bake for some time gives you the confidence to move forward with the deployment. And it's also quick to rollback since you only deployed new version of the code to small part of your application servers. All right, any questions about deployment?
Okay, when you use canary, is it automatically switched to stage 2? I mean that the second part of deployment, when you are sure that everything is okay, or it's based on humans, so you have to send some command.
This is usually done by humans, actually. So humans, it could be done by looking at metrics in AWS. So you could also make it automatic, depending how good your monitoring is. But what I've been dealing with is actually manual steps where you would actually move to the next stage.
And do you have some hour or two to decide, or it depends on the feature you deployed?
It depends on the feature. That's a good question. But you see the feature that's being deployed, and if it is high risk, you could actually like even like hold it for a day, right? Why not?
Okay. So if you are in this canary second phase, like servers of the new version, do you or ECS does it allow you to keep the logs separate from the first version, so we can look up the issues that happen on the new version?
Yeah, yeah. And this is based on the actually task definitions. So task definitions, and this is maybe the other part of the presentation that you have not seen yet, but you can, it's instrumented like that, and you can instrument it like that, obviously. All right, so if canary deployments are so awesome, why they are not supported on AWS by default? So the solution obviously is to hack it, to build this solution. So let's consider this example. You have a virtual server in EC2 with an ECS service, and this service has 5 containers. Though this is your Rails application times 5, you just have 5 instances of it. So how can we achieve a canary in this example? How can we achieve the capability to have 2 different versions of the code deployed at the same time? So what about having 2 services? So if we split our 5 containers into one canary service having only 1 container and main service having the remaining 4, we just gain the capability to run 2 different application versions at the same time. So one question will be how to actually like deploy it, right? Like if you have such setup. So there is this tool called AWS Code Pipeline, and this is CI/CD tool also used for running tests. And it has something crucial, which actually like already there were questions about, which is called manual approval. So this is a step in a pipeline which allows you to say, okay, I want to proceed with a pipeline execution, or no, I don't want to proceed. So like that's how you can basically manually specify when the canary deploy starts, and then when the second phase, the full rollout would start. And here you can see example. So yeah, canary deploy deploys. So canary deploy step would deploy new version of your code to a canary service, and full deploy would deploy your code to the rest of your containers. Okay, and last missing piece. To basically see the whole solution is to know how to start a deployment from a source code. So typically you have a source code repository and you would like to start a deployment right from there. So in this example, a push to a main branch would send a webhook to AWS, and this would actually start a release pipeline. And in this case, you can see images being built. In this case, there is like IRM image and AMD, which I won't go into detail, but basically you would build your Docker images and push them into Elastic Container Registry so they can be used later on. And another thing is that you somehow need to pass the information to your deployment pipeline, which container, which kind of image do you want to deploy. And this is done by image definitions.zip file. This file would contain your container name and its tag. And by putting it into S3, which is a storage solution for AWS, we can generate an event. This is done with another tool called CloudTrail. So basically, it observes the bucket, and when the file would appear there, an event would be generated and sent into your deploy pipeline. So let's see a full solution. So this is what you've already seen. This is just like everything at one screen, and I guess the text might not be very well visible. But yeah, like typically we would push our code to a main branch, which would then start a release pipeline building images for IRM and AMD. those images would be uploaded to ECR, and also an image definition zip file will be uploaded to S3, generating an event, which then starts a deploy pipeline. And at which point a person handling deploys could say, okay, I want to start a deploy. This would release your code version into one container, where like it would sit usually for some time, and we would observe tools like Airbrake just to see if there are any Ruby exceptions. We would be checking logs. We would be looking at metrics, if there are any memory problems, CPU problems. And when we are happy, we would only then say approve for another manual approval step, which would do a full deploy to the rest of the containers. Right. So the presentation is that was the end. Some takeaways that from this presentation that I hope you take. One is that like Ruby applications of every size can be used in ECS. Obviously, like if you don't have an expertise, maybe it's better to use some other tool. But this is a really solid tool, and it's useful when you have a small application as well as arbitrarily big one. And the second one is that canary deployments are a very safe way of deploying, especially if you have very complex environment with many dependencies. So if you have big monolith, then it's a very safe way to deploy. If you have something like microservices, maybe not, right? But for big monolithic applications, it's a safe way to deploy. And the last one is that AWS is a powerful toolbox. If something is not supported out of the box, you can actually build it most of the time. So thank you guys for listening.